Can you hear me right now? Yeah? Okay, there we are. Okay. So thank you very much for joining us to this presentation. My name is Victor Sanchez and I'm a NextLimit Product Specialist. We're going to take a look at the basics and the fundamentals of RealFlow. Actually, we're going to try to simulate a scene from scratch. And this webinar is focused on those of you who are completely new to RealFlow. If you're familiar with RealFlow, you'll probably be more than familiar with the concepts and the ideas and the workflow we're going to show right here. So let me open up a quick presentation. Okay, this is the scene that we're going to try to reproduce, that we're going to make from scratch. And you can see a very small preview right here. Okay, this is what we're going to do. We're going to interact with a couple of rigid bodies, an ice cube, this sort of ice cube colliding martini glass, and later on we will advance and see a sneak peek of a couple of new features in the forthcoming RealFlow 2013. We're going to take a look at Maxwell previews, and we're going to make a very, very simple drawback if we don't have time at the end of the session. So let me start by opening up RealFlow. We're going to click here in the new project icon, and this is very important to take into consideration. Our project, the setup of the project is going to be stored in an FLW file, while other elements of the project, such as particles, geometry, meshes, etc., are going to be stored locally in some different subfolders of the project. So let me start by showing a couple of elements, a couple of geometry elements that we have right here. We have this kind of glass and a cube. I'm going to use Maya for this presentation, but it's keep in mind that it's exactly the same thing, it's exactly the same workflow and buttons if you're using any other 3D application. If you're running with 3ds Max, Houdini, Cinema 4D, whatever, is exactly the same. Okay. So first of all, I'm going to select both elements here, the cube and the glass, and I'm going to use the RealFlow plugin in Maya in this case, and I'm going to export these elements as an SD file. The scene data file is the RealFlow proprietary format for geometry. In this case, I'm going to export this geometry because I would like to keep centralized my files together. I'm going to create a RealFlow project first. I'm going to rename it as webinar. This is the location where the project is going to be stored. By default, is made in the user folder under the scenes subfolder. And this is the complete path of the FLW file. Again, the FLW file is going to contain the setup of this scene. is going to contain the setup of the scene, but it's not going to contain the particles, the meshes, or even the geometry that we may generate. That kind of elements, that kind of elements are going to be stored in different subfolders, as we will see later. Okay, so I'm going to create a new project, webinar, and if I go to File, Open Project Folder, you'll see, let me close, you'll see right here, Stanley Scenes Webinar, the bunch of different folders that we have recently created. The webinar FLW file containing the setup of the scene, the blank scene in this case. So I'm going to start by exporting the geometry as an SD file. I'm going to save this SD file in the same folder, webinar, objects, and actually I'm going to create a new folder. I'm going to name it as assets, and I'm going to rename this file as geometry.st scene data. Okay. These options are pretty self-explanatory. I'm not going to export the whole bunch of the timeline. I'm going to export just one single frame with a geometry with both elements. In this case, we don't have animation by vertices or similar, so I'm just going to click on Export. And back again in RealFlow, this geometry SD file is the file containing our geometry data. Okay. So how do we bring to RealFlow world the data? Basically, in RealFlow, we're going to deal with basically with three kind of elements. We're going to deal with fluids, with different kind of fluids. We're going to deal with forces, and we're going to deal with geometry. So in this case, for the geometry, I'm going to click in the geometry button, then import, and I'm going to locate my webinar SD file. And take a look at this. I'm currently working in Maya. I'm using centimeters as a unit, as unit scale. And this is probably one of the most important concepts in RealFlow, is the concept of the scale. If you take a look at this grid, you will realize that approximately the base of this glass is about 10 centimeters of diameter, a radius of 5 centimeters. The thing is that in RealFlow, each one of these squares is equal 1 meter. So you must be wondering why it's possible that we have this kind of huge, really huge, like a building or something like that, glass, when we do have this real scale or real life model glass right here. Well, the thing is that for some reason, Maya exports, Maya and other 3D platforms. I have to say that I have checked this in Maya and 3ds Max basically, and in both cases the geometry is overscaled, but it doesn't really matter. We can downscale the geometry that we bring here inside RealFlow, and we have two different ways to do that. First of all, of course, we can create a locator or a group in Maya or in 3ds Max and downscale the geometry, downscale by 100 times. I mean, it will be a downscale to multiply this scale by 0.01, something like that. Then when we bring here the geometry will perfectly fit the scale. And the other way, the second way to adjust the geometry objects inside RealFlow is using RealFlow itself. In this case, we can access this button right here where we have a specific scale for geometry for fluids, both the classic fluids and the large scale fluids, and forces and demon forces. So in this case, I will recommend you to work as long as possible, work always with 1111, because RealFlow will be much more stable and your results will be much more predictable actually. But in this case, I'm going to skip this method of parenting this geometry to allocator, downscale, and then upscale because it's a little bit cumbersome and we're going to run out of time. So I'm going to go the easiest way or the fastest way, which is the fact of changing the scale right here inside RealFlow. Not a big fan of doing this, but it will be pretty straightforward and a little bit faster for us. Okay, so if I downscale this by 0.01, I just downscale this thing, and you'll see here, I'm going to delete my camera right now, and you'll see here that we have this tiny little glass with this ice cube actually. This is pretty much the real scale. If this is 1 meter, real life glass will be something like that. But the thing is that in RealFlow, especially for this kind of tiny scenes, these kind of small scale simulations, we better not force RealFlow to make a lot of calculations in such tiny space, in such a small space. So the thing is that we have to find, we have to calibrate, we have to search for a medium scale between what RealFlow can really handle in a stable and admissible time and range of simulation, and the scale that we want to the scale that we want to get at the end of the simulation. So in other words, we can scale this up a little bit. Probably for a production scene, I will use something like this, but I'm going to, in this case, I'm going to crank it up a little bit more to make the demonstration a little bit faster actually. So this is one of the most important concepts that you will have to deal with RealFlow when you firstly put your hands over it. Try to find the correct proportion between the real scale factor and the scale right inside RealFlow. It doesn't really matter if we downscale this geometry here and then we bring it to Maya or our 3D platform, because the plugin itself will invert, will make the conversion and will invert this scale in order to get it properly lined up when we get back to Maya or your 3D application. So the thing is that, okay, we have these two elements right here, and you will see that in the nodes panel I have global links, exclusive links, and nodes. This is the list of elements that are going to interact with this scene, and you will see here this global links tab. The elements under this global link tab are elements that are going to interact globally. In other words, are going to interact with everything which is right inside this bin, right inside this window. So if we want, if we have some different elements and we want to everything interacts or everything reacts with everything, we can leave those elements right here on the global links. But if for some reason we just want to specify RealFlow some different elements to react specifically with some others, if we want to apply, for instance, a wind just for this thing and not for this guy, or if we want to apply a gravity for this guy and not for this one, things like that, we will have to use exclusive links. On top of that, as fast as we can use exclusive links better than global links, RealFlow will run way faster. This is because it doesn't make sense to force RealFlow make computations to make things interact or react with other things that we are not interested in. So, for instance, I actually will recommend you, when the first time you open up RealFlow, you will find this option add to global links on. I will recommend you to disable. So you will have to link by yourself what is going to react with what. And that's a much more efficient and effective way of working with RealFlow, just because of you are forcing RealFlow to get strictly focused on what is going to react with what. Okay? So in this case, if we add a new emitter, a new classic SPH emitter right here under this tab, under this icon, you will see that we have a circle, which is one of the classic RealFlow SPH emitters actually, and we're going to throw particles from this circle in this direction, if you can see the arrow. But again, we need to tell RealFlow what is going to react with what. In this case, for instance, I may want to the particles coming from the circle react with the glass. So I'm going to link the glass to the circle, and I'm going to downscale this circle a little bit, 5 times actually. So first of all, I'm going to reset, yes, extend the timeline here, the playback actually, and you'll see that the particles coming from the circle are going to go straight forward to this arrow direction, no gravity, and just a few particles, just a bunch of particles here. So we will have to add forces. We will have to add a gravity, for instance, and tell the circle to react with the gravity. And in order to gain much more particles right here, I'm going to crank up this resolution factor. Most of the time you will be working in this area of RealFlow. Most of the time you will be dealing with this kind of parameters, and my suggestion for those of you, especially for those of you who is your first contact with RealFlow, I will suggest to experiment and to test them by yourselves, because there's a huge bunch of parameters. Most of the time, it's one of these emitters has their own specific parameters right here, and you will easily access the documentation by pressing F1 over the parameter itself. You will get this detailed explanation just by pressing F1. Okay, so nothing better than experiment. Okay, I'm going to crank up this resolution a little bit. Most of the time, it's not necessary to crank up this thing to crazy values. Most of the time, I rarely use more than 20, 30, 40, something like that. For this case, I'm going to stay below the 100, and I'm going to crank this up to 90, which is a very high value. Probably I will use a different scale in order to get much more particles, but in this case it can work for us. So I'm going to reset. And now that I have a gravity linked to the circle 01 emitter, you'll see how the circle is going to cast some particles right here. You will see these kind of disc or perfect lineup layers right here. And in RealFlow, everything is about simulate the real life, and everything's about simulate things naturally. In real life, we probably won't get this kind of perfectly lined up layers right here, so we can add some kind of randomness. And again, in order to make this behavior more organic and hide from you know, a perfectly smooth and continuous flow of the particles, I'm going to suggest you to play a little bit around with this parameter, with speed. Speed is pretty much, putting it bluntly, is like the pressure of the particles coming from the emitter. And the higher is the speed, the more pressure that we have in mind. If we think in something like a tap or a hose, for instance, it's pretty much something like that. Don't get confused with these values here. Internal and external pressure are completely different, and well, you have here in the help you have a brief explanation of what they do mean, basically. In this case, I'm going to play a little bit with this speed, and I just find that the sine function uses to work very well for me. The sine function is, most of you will be familiar with this function, is going to produce a very, very natural flow when dealing with pouring fluids and things like that, when you want to simulate things like a bottle, for instance, or tap water, things like that. So in order to get more frequency, I'm going to improve, maybe that's too much. I'm going to multiply this time 5 times, and I'm going to create an offset. I'm going to lift up this curve right here, okay, to stay in something like 2 point something. We can make, we can reduce the amplitude of these kind of waves by multiplying a factor below than 1. And again, I think something like that could work for the moment. So if I reset and hit simulate again, you will see a much more a regular flow of the liquid, of the fluid, and this is really important. These kind of things, to place some sort of obstacles right here, geometry, colliding geometry with the fluid to make it more natural, more unsmooth, actually will produce more realistic results. So if I scrub along the timeline, you will see this, again, this kind of a regular flow makes the difference when pouring something like a bottle, for instance, something like that. Okay, so now we're familiar with the 3 things, with emitters, with forces, and with geometry. I'm going to fill this martini glass with a little bit of particles, actually, and I'm going to move my emitter right here. I'm going to select a top view. Okay, in RealFlow you will find particular, very useful in particular, the ability of hide things and make things in different smooth, in different modes. So I'm going to keep this gravity active, but I'm going to hide it. Actually, I'm going to do the same with the grid. I don't need the grid so far, so I'm just going to click on G, and this time I will have a much more clear vision or perspective of my different elements. So in this case, I'm going to place this emitter right here and get back to perspective view. And for this purpose, I don't need to play with this sign function that I previously deal with it. And I'm just going to set it to a linear factor, and I'm going to click on simulate. So you will see that the circle is producing particles in the y axis. Okay, we have x, y, and z right here, and we have this color code. This color code gizmo, this color code indicator, to inform us that this is x, y, and z. So I'm going to mention that if you're using a different software than the main one, than Maya in this case, you may want to adapt or adjust your axis setup. So bear this in mind. If you're running with Lightwave or Cinema 4D or 3ds Max, you may want to change this setting. And depending on the y-axis, you may want to choose one way of Maya or another. This is the one that works better for me, the Maya default. Okay, so I'm going to simulate a little bit more particles. We're not having too many particles right now, but it can work for our purpose. So okay, I'm roughly 19,000. I click on simulate to stop the simulation, and we have two different ways to stop the generation of particles. In one hand, we can simply set the speed to 0. So if the speed is 0 and I click simulate, the circle emitter will not generate more particles. The other way is to specify a maximum number of particles right here. So if we are in 19,000 and I set up here 20,000, that's okay. When I click simulate, the circle emitter won't generate more particles. So in this case, I would like to start my simulation in this state. So for this purpose, I can create an initial state right here. Under use initial state, I can say, okay, I want to make an initial state, use initial state to yes, and reset to initial state. So if I reset again, my simulation will begin with these already simulated particles. If we take a look at the project folder, right inside the initial state folder, a binary file is going to be stored containing the information, basically the position and the location and the IDs of this batch of particles right here, okay, 2 megs roughly. So with this in mind, I have my initial state, I have my fluids right here, and we can have a little bit of action by making these rigid bodies interact with the fluid. So for this purpose, I'm going to tell RealFlow that this cup of glass is going to be a rigid body, passive rigid body in this case, and this glass is going to be an active rigid body. Okay, so I'm going to put this on smooth, and I'm going to put this on flat shaded, for instance. Okay. In this case, we need to tell RealFlow that this guy is going to fall and collide with the fluid and with the glass. So I'm going to add the links for the Martini glass and for the ice cube itself. For the ice cube is going to react with the gravity, and of course it's going to react with the fluid, with the circle emitter, and certainly it's going to react with the Martini glass. It's going to bounce with the Martini glass. And the Martini glass, in this case, is a rigid body, but it's a passive rigid body. Passive rigid body means that these kind of objects are going to have infinite mass, and they will be able to make other active rigid bodies react with it, but they won't be affected by external forces such as gravity, wind, vortices, attractors, things like that. So the passive rigid body is a state suitable for things like floors, for everything that you want to keep static, while the active rigid body is going to move and is going to write a sort of animation here. So in this case, I actually can remove the Martini glass from here. And if we simulate, you will see that the ice cube is falling down because it's an active rigid body and is affected by the gravity, and the glass will behave just as a simple collider for the ice cube. So we're gonna get this behavior. Very interesting. I'm going to hide the fluid at this moment, and here you'll see that the ice cube is colliding with the glass. Okay, what happened with the fluid? The thing is that I have to tell RealFlow that I want the fluid to be affected by the glass. So I forgot actually to tell the circle is going to react with the ice cube. If I reset and simulate again, you will see that in this case the ice cube will move this kind of fluid. If we take a look at the project folder, this sort of animation, this sort of geometry, of keyframe geometry actually, is going to be stored here with two different types of files. In one hand, we have this animation SD file. In the other hand, we have these cache BDC files. Okay, the animation SD file is a file actually that you will find inside the objects folder, where the keyframes and actually the triangulated geometry is going to be stored. So RealFlow is writing this geometry in triangles, and it's writing actually the keyframes frame by frame in this animation SD file. The BDC files are actually useful to stop and resimulate and resume the simulation right here and things like that, but they're not useful for bring it to our animation or bring it to our 3D platform. What we're going to bring back to our 3D platform, what we're going to use as a keyframe driver is the animation SD file, which you will see later. Okay, let me, if you see here, actually I can go to the last cast frame or the last simulated frame, and you will find in particular a very useful daemon is the killer volume daemon. Under these forces, you will find out these sort of forces, these sort of tools actually with the letter key as killer, because they're killers actually. They kill particles, in fact. So if you see, I can determine that the volume where my simulation is going to happen, and you'll see I'm going to link the clear volume to the circle. You will see how the particles are going to disappear once they reach the limits of the clear volume. Okay, a little bit more. Okay, so there you have, all of them are disappearing. Another useful, let me hide the icon of the clear for a while. Another useful usage of this killer volume is as in inverse mode. I can set inverse and it's going to happen exactly the same. I can place the killer just right here, and if I click on simulate again, from this point, the particles are alive, are going to collide the edges of the glass, and finally they will fall down until this kind of stopper, this kind of eraser, particle eraser actually. Okay, so just killer volumes are very, very fast, and you have a different bands. You'll see what some of the particles are passing by the limits of the killer, but those particles who are falling inside this volume are going to be killed. You'll find very, very particular this kind of killer depending on speed, depending on the age of the particles, if they're isolated or not, or if they collide or not with other objects. Killer volumes will make your simulations faster if you remove those particles that you don't need to simulate and you just get focused on those particles. For instance, those particles that are going to be on shot of the camera, and it doesn't make sense to force RealFlow to simulate resources that you're not going to deal with actually, or you're not going to add out of the camera. So in this case, let me get back to my initial state. I'm going to remove the killer actually, and I'm going to paint the grid. In order to make this a little bit more interesting, I'm going to create a plane like a floor, and I'm going to change the state of the glass right here. I'm going to select it as an active rigid body, and again I'm going to make the floor as a passive rigid body. I have to tell RealFlow that now the martini glass is going to be affected by gravity and is going to be affected by the plane itself. It's going to be sit on the plane, it's going to be sit over the plane, so it's going to be affected by the plane itself. And of course, it's going to be affected by the ice cube right here. I'm going to hide Raul. And okay, so with this in mind, I can either decide if I want to the glass to react with the circle, with the fluid itself or not. The difference will be that probably it will be more natural if the whole mass of fluids is going to move in a single direction. It will probably create the glass to move along with it. And so in this case, I'm going to I'm going to embed in the bands of linked nodes right here. You'll see again that my global links is completely empty. Most of the time, if you work in an efficient way, most of the time your global links will be completely empty, because it doesn't make sense. For instance, it doesn't make sense to force RealFlow to evaluate or to calculate this guy with this guy, or the gravity with this passive rigid body. So in this case, it's better to decide what is going to react with what. Okay. So in this case, I don't know if all the players are in C. Let me put this guy as a bounding box. Another interesting tool or another interesting trick to accelerate the time of your simulations will be, in one hand, to decrease the number of substeps. By default, we do offer 1 as a minimum substeps and 333 as a maximum substeps. Substeps are pretty much like the steps in between frames. For those of you who are familiar with simulation software, you will perfectly realize what I'm talking about. For those of you completely new to this concept, let's say that the substeps are like frames between frames. I mean, from 0 to 1, we need to cover a few steps. We need to evaluate what's going to happen in between from the frame 0 to the frame 1. And obviously, depending on the number of substeps, the simulation will be much more accurate or will be more poor in technical terms. In this case, we rarely need 333 frames. I'm going to decrease it a little bit, and you'll see that they will realize. You will realize that there will be the simulation will be a little bit faster. Another interesting trick to accelerate your simulations is to disable the viewport. If you click on View, Alt, Disable Viewports, or you just click Alt-D, you're going to disable the viewport, and RealFlow will skip all the OpenGL stuff and will definitely go way faster when you simulate. You can even earn up to 20-something, 30% of the time if you simulate with the viewport disabled or not. I'm going to enable it again, and in order to make things a little bit more interesting, I'm going to select a top view, and I'm going to move this guy here. You will see that when I click on the imported geometry, we have this SD curve tab right here. It's pretty much like a lock, like a security lock. While the geometry is imported by default, I can move it. I cannot move it. This is because it's kind of locked. It's kind of protected in some way to preserve the geometry that I bring from my 3D platform. If I click on this button right here, I will be able to move the geometry. And I have to tell that if you want to deal with curves, if you want to later on, you will have to deal with animated elements, as we're going to do in this case. You will definitely have to break this SD reading and turn it to the curve reading by pressing this button right here. So if you take a look at the X tab right here, I'm going to select a top view in the X axis, pretty much like 1, 2, 3 units, pretty much 3 units. And in this case, I'm going to apply an initial speed to this rigid body. I'm going to apply velocity in negative X of, if I apply a negative velocity of 3 in X axis, it does means that in 30 frames with no external forces on this guy, my ice cube will cover 3 units, 3 meters actually of distance. And in this case, I'm going to compensate the force of the gravity by adding an extra meter. Let's see if I get it or not. And I'm going to bring back this glass to wireframe, and apparently I think all my actors are ready in the scene. I'm going to reset and hit simulate. Let's see what we get. Okay, so we see the ice cube is falling with this negative X direction, and at the same time is falling by the force of the gravity. and if everything goes okay, I think we'll be lucky and get the the ice cube inside the glass. A little bit more. You see, by the way, that the simulation is a little bit faster than the previous attempts, and this is because the force, because the impact of the downloading the not downloading, downscaling or decreasing the number of maximum substeps. So in this case, you will see how the Martini glass is already affected, not too much actually, but the cool thing is that we can play with the mass of these elements. So in this case, if I don't know if you will be able to watch it, but if I scrap the timeline a little bit, the glass is moving a little bit because of the impact of the glass, not too much. And this is because we probably need to tweak the different masses of the objects. If I click on this guy here, I have the mass to 30. I'm going to, actually not, actually I'm going to increase it. I'm going to double it to something like 60. And for this guy, I'm going to put it in the half. So again, if I press A or click on simulate, you will see how the, in this case, the glass is going to be heavier, and the ice cube is going to be heavier, and the glass is going to be lighter. By the way, if we take a look at the particles folder right here, all the binary files, 19, 18, 20, all these frames are going to be written in these binary files per frame. Okay. Again, if we do, let me put this guy in wireframe, for instance, and you see, well, not too many, not too much movement, not too much different from the previous result. Another trick that we can use is to decrease the friction from the glass and the floor right here. I'm going to click over the rigid body tab, and under object friction, I'm going to reduce it drastically. Same thing for the floor. And this is pretty much the way you will work with RealFlow, is fine-tuning your parameters here. It's pretty recommendable to change one by one parameter and then make your test, because if you change several things, you won't be able to determine what is going to take part in the changed behavior of your elements. So it's all about changing one thing by time, one thing per time, and trying to discover what is going to happen right here. With a little bit of practice, you will get familiar with most of these elements right here, and you will probably in a few weeks be you will feel very comfortable with the help, the F1 help that you have right here, and of course with your test and your different scenes. Okay, so this is going to be more interesting. Now we have decreased the friction of both the glass and the floor, and I'm going to wait a few frames more, maybe until 4 and 5. Okay, I'm going to stop right here, and I'm going to decrease my timeline right here. So if I scrap the timeline, we have this thing. Okay, we have the scene properly, let's say properly simulated, and you'll see how the glass is perfectly moving, consistent with the movement of the ice cube. Okay, so now we do have several ways to bring back this simulation to our 3D platform. We can, let me show you a quick diagram, and I will tell you about the 3 different ways that we have to deal with this scene. We have option A, B, and C. Option A is to use the RealFlow render kit. With this option, we will import the particles themselves right inside our 3D platform, and we will mesh them at render time. We will skip the meshing or the surfacing process. For this purpose, you have to count on RenderKit licenses, and for those of you who are already using Maxwell Render, I have to tell you that the RenderKit tools are already, the RenderKit functionalities are already embedded inside the Maxwell Render engine itself. So you don't have to purchase, you will not have to purchase additional RenderKit licenses for your pipeline. Okay, that's in the case of using Maxwell Render. If you're using other rendering solutions such as Mantra, MetalRay, or even Cinema 4D, and RenderMan, you will be able to purchase these RenderKit licenses. The other options are meshing right inside RealFlow. For this purpose, you can determine, you can use the two different kind of meshes. In one hand, you can use the particle mesh render kit using the RenderKit algorithms. Don't get wrong with the RenderKit name here and here. This is probably an ambiguation that we probably will sort out in the next revision of RealFlow. But the thing is that you can use this kind of RenderKitMesh right inside RealFlow to generate the meshes, and you don't have to deal with any other additional RenderKit license or things like that. This is meshing, creating geometry right inside RealFlow. You will generate the mesh, you will generate the bunch of triangles, vertices with velocity and speed to make motion blur, things like that, right inside RealFlow, and you will be able to embed them into your platform. There is another option, which is to use the standard mesh. The difference between meshing with one way or meshing with RenderKit or meshing with standard is pretty simple. The standard mesh is just a legacy option that we have for, and we actually keep this option for compatibility purposes. I will definitely recommend you to use the RenderKit mesh because first of all, because it's multi-threaded, which is not the case of the RenderKit, of the standard, of the legacy mesh, let's say. And it has, from my point of view, much more controls and better controls than this one. So again, we just keep this one for compatibility purposes. As fast as possible, as long as possible, try to use this RenderKit mesh right inside RealFlow. So I'm going to click on this one, and if I actually do have the possibility of embed different emitters inside this RenderKit mesh. But in this case, as I just have one single emitter right here, RealFlow will automatically embed the emitter for me. If that's not the case and I need to select any other emitters, just by right-click over it, I can determine what emitters I'm going to associate with this mesh. So if I just simply build this mesh here, I'm going to hide the particles. I'm going to show this guy. Okay. So in this case, we do have this kind of blobby thing, and again, it's all about dealing with parameters just right here. You don't have to touch everything. Most of the time, you will be able to build very nice meshes with just by tweaking a couple of values. For instance, the polygon size, the smooth, and the filter is, I'd say, in the 90% of the times is everything you will need to deal with. Same thing with the radius, and forget about the rest. I mean, from my experience, just by touching those 4 values, most of the time you will get successful. Let's begin right inside here by the circle inside the RealFlow mesh. In this case, I'm going to reduce the radius of the metaballs that are going to create this mesh. I'm going to drastically reduce it to something like 0.03, and I'm going to reduce a little bit the size of the polygons right here. I'm going to keep this smooth this way, and I'm going to use the filter in order to get a much more realistic results. Take care with the filter. The filter is, if you can take a look at the help, the filter is a method that we actually embed inside RealFlow to get faster results with less effort, putting it bluntly, but try to not to abuse too much of the filter, because abusing of this filter, of this relaxation in excess, may end up with these kind of cheese holes in the fluid, which is really, really awful. So I will recommend you not to abuse too much on the filter. By default, I always try to begin with 32 or 64 steps. So in this case, if I just click right here, maybe it's, again, too much filter, and I'm going to try to decrease this guy a little bit, and maybe something like that. Okay, so this is much more adequate, or much more closer than what we're looking for. Okay, so with this option, once you are happy with the mesh, you can bring your timeline here to 0 and click on this script to build the whole bunch of meshes. RealFlow is going to, if we take a look at the project folder, and Stanley scenes, meshes. Okay, here, just right here in the project folder, we do have here the binary files for the whole bunch of meshes. So with this in mind, we can go up to, we can bring back here to our focus tool to Maya. And with this in mind, we have 7 different options. We have several different options. In one hand, we can bring here the bin meshes with this button here, with the RealFlow plugin. And I'm going to bring here webinar meshes. And create. Okay. So this is the mesh that I have previously generated in RealFlow. Okay. This is the triangulated. This is geometry embedded inside the Maya scene. For those of you using Maxwell Render, I will definitely recommend you to make use of the plugin, of the Maxwell plugin itself, because you will be able to import the actually not to import in the scene. You will be able to reference the meshes in the scene. Maxwell will read them on render time. So with this plugin, with this button right here, you will have to the possibility of not to embed the geometry, just reference the geometry to external binary files. And the advantage of this way are pretty obvious. Your files will be way lighter, and your workflow will be way faster, obviously. On top of that, you can easily increase the motion blur factor with this factor just right here instead of dealing with the camera or things like that. Okay, the second part is bring here the animation. So I'm going to click on the SD import, and I'm going to locate my webinar folder, objects, animation, SD. So if you take a look, I'm going to smooth the glass. The movement is absolutely consistent, and by the way, is scaled, is properly scaled without any problem of the scale that I use right here. Okay. So with this in mind, I'm going to select this frame, for instance. I'm going to get rid of the plane. By the way, when you import an SD, the way it works is that if the objects are present and active in the scene, if the objects exist in your scene, RealFlow will simply paste the keyframes over them. If your objects doesn't exist on your scene, if you open a blank scene and you import an SD file, you will get the same objects but triangulated. So better to obviously to keep them original in quads if you can. So in this case, I'm just going to open up Fire, for instance. Okay, so I'm going to add a new material for this guy that is going to be a kind of water. And for this thing, I'm going to create a new material that is going to be like glass, high-grade glass. Okay. So if I click on render, you'll see the physical sky by default, Maxwell physical sky by default, and the glass and the fluid, everything right side in. Let me disconnect the physical sky a little bit down, and use an HDR for the scene, and bring here this studio, and I'm going to use a render cab that I previously had. So in this case, I'm going to tweak a little bit the fluid. This is kind of water, right? So if we want to tint this water, we just need to select the color. Will be transparent again, and this is because of the attenuation distance. Technically speaking, the attenuation distance is the distance that the light must cover in order to lose 50% of its energy. So if I just click render, okay, here we are, and again, this will be matched the result. Okay. Okay, I'm going to close this here, and I'm going to very fast go through a couple of new features that you may want to take a look in the forthcoming RealFlow 2013 version. In RealFlow 2013, we have introduced a lot of new features, and there are a lot of videos and a lot of documentation about what's coming, but I would like to show you a couple of things right now. Bear with me, this is just an alpha version, so just make a very simple scene. One feature for those of you who are familiar with Maxwell is the possibility of get previews, very realistic results, very realistic previews right inside RealFlow. I'm going to work with a global scale of 1 because it uses to work way better. So if I click on this icon right here, you will see that we do have an immediate feedback of my scene right here. I do actually have a few bunch of nodes of materials, sorry, most of them related with things like fluid, I don't know, T for instance, things like that. Okay, so if you're going to deal with fluids right inside here, you will have a lot of materials specifically for fluids. It works very well. We couldn't talk too much about RealWave, but it works very well with RealWave. Actually, RealWave is a tool for open wide scenes, things like that. So if I reset yes, set this thing to 0, actually to smooth shaded, and tile this wave a little bit, okay, and assign a material to this wave that is going to be water, ocean, and yeah. Okay. RealFlow is going to export the wave, and we're going to get very realistic results. Let me probably tile the wave. I'm going to close fire and tile the wave a little bit more. Okay, and now I'm going to crank up the scale of this guy. Sure. Okay. So the thing with Maxwell is that you will easily get immediate results, immediate feedback without concerning about, you know, those classic hundreds of parameters in other rendering solutions, such as, you know, bounces or sampling methods, things like that. So you will get very, very realistic results in seconds. And the good news is that you will be able to generate previews by sending your scenes to the farm. So hopefully most of you, especially for those of you who are not familiar with Maxwell yet, you will definitely end up loving this tool because it's really, really, really nice. There are a lot of major improvements, and unfortunately we're running out of time. But another important tools that a bunch of tools that we have completely revamped in RealFlow 2013 is the technology for large scale fluids, the Hybrido technology. Hybrido works in a different way as the classic speed solvers. Hybrido is actually a mix. It's not a solver itself. It's a mixture of different technologies. This is going to be the core, technically speaking, in both senses, the core of the fluid and the core of the simulation. We're going to create a domain, and we're going to use geometry as a streamer, as a source to generate particles right here. And we're going to create an emitter. This is basically the 3 elements that I need for an hybrido scene. I'm going to link the emitter to the grid, and I'm going to tell the emitter, actually RealFlow does it for me if I just have one geometry object in the scene. On top of this, I'm going to add a gravity, and you will realize that this relationship editor is completely new compared to the old relationship editor. We believe that this way is going to be much more faster, much more clear, and definitely much more powerful. Don't think in this relationship editor as a flow diagram, things like that. You will see that everything is going to flow in some different directions. Okay, so this is not like if you compare like with other software tools like Houdini, for instance, where there is a clear flow in one single direction or things like that. This is a completely different approach. In this case, I'm going to, I'm going to reset, yes, and hide this guy here and simulate. Let me, I have the command line option by default. Let me check on here, and you will see that immediately how fast is Hybrido when dealing with a bunch of particles. In the other example, we had to wait frame by frame, but Hybrido, especially for large-scale simulations, is really cool. Let me add a new element. I'm going to add a sort of internal walls to make a sort of dam break or something like that. Here I'm going to tell RealFlow that I want this guy solid outside, and he's going to be upscaled a little bit as a bounding box, for instance. Okay, so the source is something like that, probably something this way. Okay, so again, I'm going to hide the source and click on simulate. You'll see again how fast is the simulations. Hopefully, very soon we'll get a detailed step-by-step Hybrido webinar, and we will show you different ways to make things like, waterfalls, floods, trails, things like that. So this is the way of working with Hybrido. Obviously, on top of this, you can add dynamic objects, moving objects, or static objects as you want, something to collide with. And the idea is to work with Hybrido in a first step as a core fluid, and for those areas where we need more resolution, we will add secondaries, we will add splashes, we will add foam, we can even add mist, we can add wet areas, things like that. This is the Hybrido technology that is completely revamped in RealFlow, and unfortunately we're running really out of time. So I'm going to wrap up this presentation right here. I want to thank Rosanna for his job, and all of the RealFlow team, Angel Tena, Gus, Sanchez, Luis Miguel Mora, Alex Ribao, Gilco Corts, Enrique Turegano, and Katie Norris as well, for helping us in the lineup of this webinar. And hopefully, for those of you who were not familiar with RealFlow, you will have some first steps to learn and to get familiar with the basics and the fundamentals of this fantastic tool. So thank you very much, and I hope to see you all again very soon. Thank you.